Hello, my name is Logan Deary, and today my presentation for building energy modeling will be on green buildings and the different parts of the green building that can save energy.
So here's an introduction to green buildings and sites. A green building refers to both a structure and the application of processes that are environmentally responsible and resource efficient throughout a building's life cycle. And that refers to both planning, to design, construction, operation, maintenance, renovation, and demolition. Three main parts of a green building, that being building envelope, which is windows, walls, roofs, foundations, and then lighting being artificial lights, natural lights, LEDs being artificial, and then daylights and skylights being natural light, and then heating and cooling concepts. Some examples would be solar heating, heat pumps, ground source heat pumps, different forms of ventilation. There's chill beams, earth tubes, and chillers. Now I'm going to show you some real-world applications of these concepts at a job site. So the first part of the building envelope that I'd like to talk about are windows. These are CGI storefront windows. They're low E glass. Low E glass or low emissivity glass was created to minimize the amount of infrared and ultraviolet light that comes through your glass without minimizing the amount of light that enters your home. That means that it'll let the light in, but it doesn't let the heat in. Therefore, you don't have to pay as much to cool your house down. So the second part of the building envelope that I'd like to talk about is the wall. So what's great about these walls is that there's 8 inches of concrete and then 3 to 4 inches of insulation, which give these walls very high R value. The material's ability to insulate is quantified by its R value, which measures resistance to heat flow. The higher material's R value, the greater it is at insulating and the lower rate of heat flow through it. So a typical wall in a house or any building has an R value from 13 to 23. I couldn't give you the exact amount for these walls, but they're probably up in the higher range around 23. The third aspect of a green building that I'd like to talk about is the light. So modern technology and artificial lighting has greatly advanced. The new thing is LED lighting, which uses up to 90% less electricity than other conventional bulbs. And on top of that, they don't use toxic gases like argon that are in incandescent bulbs. So in this house, you can see up high, these are all LED lights, but the lighting that also is available behind you, you see, is all the natural light that comes, which is free, doesn't require electricity. So as long as your windows are low E and they don't bring the heat in where you have to cool them more, the best form of lighting that you can get in a house is natural lighting. So another aspect of this building that's green is its air conditioning system. So what I mentioned before in the slides, like the chilled beam and the ground source heat pumps, are all great, but they're either not really useful down here in South Florida, or they're really only for large industrial commercial use. So what we have behind here are three AC handlers connected to the compressors that are outside. And these are equipped with variable air volume and variable speed compressors, which save the electricity bill up to 30% here. So how those work is they only give the air that is needed for a specific area in the house. So if a bedroom needs to be cooled, only that bedroom will be cooled. And it'll send the amount that it needs, not an insane amount of cooling. So now I've brought you onto the balcony to talk about the last aspect of this home that's green, that being its roof. So what you see here, or rather what you don't see here, is all the insulation that's on top of this roof. So you see about a 2-foot fascia here. The bottom 8 inches or so being framing, but then the rest of that is all insulation. So roof coverings on top of buildings are continually heated by the sun. On large buildings, roof surfaces in the summer can easily reach around 150 degrees. So having the insulation on the roof helps insulate the house and not heat by that 150 degree heat that we exceed here in South Florida. So green buildings have standards and certifications, also known as rating systems. There's 3 main certifications that you could get for a building. Most popular being LEED. LEED stands for Leadership in Engineering and Environmental Design. It's a green building certification program that recognizes best-in-class building strategies and practices. LEED certification is available for various types of building, including commercial, residential, and industrial. Second being Green Globes certification. It's a rating system for green buildings design, operation, and management. Their certification process involves a self-assessment by the building owner and an on-site assessment by a third-party assessor. Last one we have here is the Living Building Challenge, which is a green building certification program that requires buildings to be regenerative and self-sufficient. The certification process involves a rigorous evaluation of the building's performance in 7 categories, including site, water, energy, and materials. So if you think of a green building, you may think of what it would look like, big tall building covered in plants, and does have something to do with it, but not everything. So there's no green building style. A green building can be designed and built in any architectural style and generally looks like any other building. It's measured by performance other than aesthetics. It uses energy and water efficiently. It protects the health of its occupants and its environment. It conserves natural resources and uses materials that are not harmful or polluting. Some aesthetics are chosen by the region in which the building is in. Each green building is adapted to its local place. Buildings use different climate strategies if they are located in different regions. For example, a green building in Arizona isn't going to look like a green building up in a cold part of Canada because they need different strategies to combat the climates that they're in. A green building must be attractive in order for it to truly be green, because in order for it to be green, it needs to be recycled over generations. A good example of this would be super old buildings over in Europe that have been there for hundreds, thousands of years. Those are green because they'll last forever, they look good, no one wants to tear them down, and new resources are not being consumed in construction, and demolition waste is not being sent to the landfill with those buildings.
Thank you for listening to my presentation. My name is Logan Deary, and I hope you enjoyed watching it.